In this video, we're going to discuss the average rate of change of a function. This is going to be an important idea moving forward. It's one of the relationships we want to consider. We want to think about how as we progress along the input axis from a starting point, let's say x equals a, so a is our starting input value, finishing at x equals b, so b is our ending input value, how did the function change? So we look at what's called the average rate of change. To compute the average rate of change from x equals a to x equals b, there's two ways to think about it. The first one is to think about the change in output divided by the change in input. So that's how did our output change divided how did our input change. Formula-wise, to find the change in outputs, we take the output at B and subtract the input at A. So f of B minus f of A over B minus A. This formula will specifically tell us how we expect our function to change when we increase the input by 1. That's going to be a very important idea in our next video when we start looking at some interpretations of the average rate of change. In this example, instead of an f of x formula, we're going to use g of x. G of x equals x cubed minus 3x. So to find our average rate of change, in this case, from x equals a to x equals b, we're going to use the formula g of b minus g of a over b minus a. All right, so let's find the average rate of change from x equals negative 1 to x equals 1. So in this case, our a value, our starting input value is negative 1, and our ending input value is positive 1. To use this formula, I need g of a and g of b as well. G of a would be the same thing as g of negative 1. G of b would be the same thing as g of 1. So to find g of negative 1, I need to plug negative 1 into the formula. Negative 1 cubed minus 3 times negative 1. Negative 1 cubed is negative 1, and negative 3 times negative 1 is positive 3. G of negative 1 is 2. G of 1 would be 1 cubed minus 3 times 1. That's 1 minus 3 is negative 2. So these are the four parts of my formula. A, B, G of A, and G of B. So now the average rate of change would equal G of B minus G of A. That's negative 2 minus 2 over B minus A. 1 minus negative 1. Those are just the parts of the formula plugged in. So this would give me negative 4 over 1 minus negative 1 is 2. Negative 4 over 2 is negative 2. The average rate of change would be negative 2. Let's find the average rate of change from x equals negative 1 to x equals 3. So the starting input value, the a value, is negative 1. The ending input value is 3. So if I want to find g of a, I'm really finding g of negative 1. And we've already found that in the first part, g of negative 1 we know is 2. G of b, the output value at our ending input value of 3 would be the same thing as g of 3. That is 3 cubed minus 3 times 3 is 27 minus 9, which is 18. So let's compute the average rate of change now. It's the change in outputs, the G of B minus G of A. So 18 minus 2 over B minus A. 3 minus negative 1. 18 minus 2 is 16. 3 minus negative 1 is 4. 16 over 4 is 4. We can also compute the average rate of change from a graph. And in this case, it's often helpful to think about the average rate of change as being the change in output over change in input. Okay, so we're given the input values. We want to find the average rate of change from x equals negative 4 to x equals negative 1. When x equals negative 4, let's find the corresponding output. Here is the point when x equals negative 4. When x equals negative 4, the output value is 1. When x equals negative 1, the output value there, the level is up 1, 2, 3, 4, 5 places. F of negative 1 is 5. So here, the average rate of change between those 2 points would be 5 minus 1 over negative 1 minus negative 4. 5 minus 1 is 4. Negative 1 minus negative 4 is 3. 4 over 3. Since 4 is not divisible by 3, we should just simplify the fraction. 4 over 3 is simplified, so that would be the average rate of change here. Let's find the average rate of change from x equals negative 4 to x equals 0. We know when x equals negative 4, the output level there is 1. We found that in the previous problem. How about when x equals 0? Here, when x equals 0, the output is 3. F of 0 is 3. So let's compute the average rate of change. The average rate of change is the change in outputs, 3 minus 1, over the change in inputs, 0 minus negative 4. 3 minus 1 is 2. 0 minus negative 4 is 4. While 2 is not divisible by 4, we can reduce the fraction 2 over 4 to 1/2.